In our previous videos, we were talking about solving absolute value equations. So next we're going to talk about absolute value inequalities. Now with the absolute value, when we talked about equations, we had two equations because we had two distances from zero that were the same. So with inequalities, it's going to be a similar idea. So before we actually get to the absolute value piece, we need to go back and review our compound inequalities. So a compound inequality is when we have two inequalities joined by the word and or the word or. So we just solve each part, and then our graph is going to be each piece on the same number line. Now when we're talking about an and statement, sometimes you might see it called an intersection, but our final answer, meaning the graph piece of it, has to satisfy both parts. So if we're talking about shading, we would only shade the part that overlaps. And if parts don't overlap, then we would have a no solution answer. Now with or, sometimes we call that a union. And for our final answer, we need to include all the shading that makes either statement true. So it's not just the overlap shading, it's the shading for all of it together. And again, when we're talking about this situation, it's in terms of our answer, which is x. So when we're graphing, we are graphing on a number line. Okay, so to start with, we're just going to go over what the graphs would look like for each situation. Okay. Now when you're making your graphs, I don't want you guys making a ton of little tiny tick marks. So if we have two answers, we're just going to put both numbers, so smallest one should be on the left, so this will be -2 and 5, and then we would fill in our graph accordingly. So here we have an and statement, so I can only shade the overlapped part. So if it helps you, you can make a separate graph. So if I'm thinking about -2, this is an open circle, greater than I'm shading to the right. So 5, I have that bar underneath, so that is a closed circle, and if it's less than, I'm shading to the left. So I can only shade where the lines are going to start to overlap. So since they're headed towards each other, that means that your shading would be in between these. So only the parts that are overlapping. Okay. So if we look at the next one, that's an or statement. So that just means that I need to shade all the parts that are going to be true. So again, I'm just putting my numbers on here. So I would have a closed circle at -2 this time. And then or is less than, so I'm going this way. And open circle this time at 5, greater than, going to the right. So I would include both pieces if we had an or statement. All right, so -2 and 5. Okay, so if we are thinking about what this would look like, so notice how our signs are pointed the same way. So normally I would put a closed circle here. So I'm going to do this lightly in pencil just so I can show you guys. So closed circle. And then this one would have an open circle. And here I'm going to the right. And then this part I'm going to the right. So my overlap doesn't actually start until I get to this part right here. So on my graph, that is the only thing that I can include. So I'm going to erase this. So where it starts making both statements true is at this piece right here. So this is the only part of the graph that I can have shaded. All right, now if it was an or statement, so like on the next one, so again, notice how they are both going in the same direction. We have to include the parts that would make both true. So I actually need to start back here. So closed circle, shaded to the right. And then this piece is covered by here because I would have an open circle and then shading this way. Okay, so or we include everything and we include the overlap. All right, last couple here. All right, so notice how they're going in different directions. So again, if you need to kind of make a separate graph. So open circle going this direction. And then for this one, closed circle going this way. So notice how when I shade them, they're not going towards each other. So there is no overlap happening. So if there's no overlap, that means that there is no solution to this, and I shouldn't have any shading on that number line. Okay. Now if we see it as an or statement, so like on the next one, so again, -2 and 5. So here I would technically have that closed circle shading this way, and here I have an open circle, and then I'm going this way. So because it's an or statement, there's actually no stopping point on the graph. So this open circle doesn't matter because I'm already shading over it. So this would be an example of infinitely many solutions. Okay. So or statements, we can have a situation where we get infinitely many, but it's not possible to get a no solution answer on an or statement. And statement, it is possible to have a no solution because there might not be any overlap, but it's impossible to get this infinitely many where the entire number line would be shaded. Okay. And then I also wanted to make sure you guys were aware that sometimes with our and statements, they can be written together like this, and I would just leave them together. So if you have to shade, since x is in the middle, that means that your shading would go in the middle. So we would have a closed circle at 3 because that one has the bar, open at 4, and then shading in between. Okay. Now, if you don't like that, you can separate it. So if you did want to separate it, we would cover up this part. So we would have -3 less than or equal to x, and then we would just need to flip that around. So I would put my x over here and -3 over here. So that means I need to flip my inequality symbol. And then we would cover up this side next. So this would just be x less than 4. And then we would write the word and in the middle. All right, so those are what our graphs are going to look like. Now, if we did have to write our answers in interval notation, so if I just go back up and look at the graphs, remember we do a parenthesis with an open circle, bracket with a closed circle. So on that first example right here, if I had to write my answers in interval notation, this would be -2 to 5, and the 5 would get a bracket. Okay. This one, our interval notation, so it's coming from -infinity to -2 with a bracket, and then we skipped stuff, so I need to put my U symbol there to connect them. And then I'm going to have a parenthesis starting at 5, going towards positive infinity. Okay. On this one, let's see here, so parenthesis at 5, going towards positive infinity. And infinity always gets a parenthesis. Here I would have a bracket for -2 going to infinity. And then if it's a no solution, interval notation, we just say the same thing, so this wouldn't change. And then if it's infinitely many, we would just have to write it as -infinity to positive infinity like this. So that is our interval notation for that. And even on this example, again, looking at my graph, bracket at -3 to 4, 4 gets the parenthesis.